Good morning students, welcome to Royal Palace Peak College online classes. Still in the previous classes I was discussing about the theory of electrochemistry. Now from this video onwards I will be dealing with competitive classes. As the lesson or the chapter solid state is completed in your offline class mode, so it is already completed for you. So I am going to start directly with the CET or the Neet part. Okay, let us continue with the questions here. Which of the following is an example of covalent solid? Okay, we have silicon carbide, barium sulfate, dry ice, and iodine. Silicon carbide, barium sulfate, dry ice, and iodine. As you know, solids are classified into different types. What are they? Ionic solids, molecular solids, covalent solids or network solids, and metallic solids. In this, the question is asking about covalent solids. Covalent solids means the bonding exists between them is covalent bond. Whenever there is electronegativity difference between the elements is less, then covalent bonding takes place. And whenever there is electronegativity difference between the atoms or the bonding elements is large, then ionic bonding takes place. Let us see this. Silicon carbide. Silicon and carbon, they are almost all the same elements and they are having almost all the same electronegativity. So here covalent bonding can take place. In this barium sulfate, barium S block element, almost all the solids are ionic in nature. Dry ice is a molecular solid. Even this one solid iodine is also molecular, but we are covalent solid. So answer is silicon carbide. Coming to which of the second question? Which of the following is a molecular solid? Now they are asking about molecular solid. MgO, magnesium oxide, AgCl, silver chloride, carbon dioxide, and palladium. Now, here magnesium oxide. Magnesium belongs to S block element. Magnesium oxide, as you know, it is ionic bond. Ionic bond exists. Similarly, Ag plus Cl minus ionic compound it is. They want a molecular compound. Molecular compound here Pd is palladium. It is metal. So carbon dioxide. Generally, dry ice or solid carbon dioxide is considered as molecular solid. Third question. An example of an ionic crystalline solid is diamond, purely covalent in nature. It is network solid. Silica, SiO2 is also covalent compound. Iron, metallic compound. Lithium fluoride is S block fluoride, S block halides. They are ionic in nature. So the answer is lithium fluoride. Coming to fourth question. In which of the following pairs both the solids belong to same type? Now they are given pair of compounds in the options. They are asking which of the following pairs both the solids belong to same type. Means either both must be ionic, or both must be covalent, or both must be metallic, or both must be network solids. Okay, so all molecular solids. Now what is this first option? Solid CO2 and zinc sulfide. As you know, zinc sulfide is which type of solid? It is ionic solid, and solid CO2 is molecular solid. So these two belong to different category. Calcium fluoride is ionic solid, pure calcium is metallic solid. So that is also different combination. Graphite is covalent or network solid, and ice is molecular solid. Whereas silicon carbide is covalent, as well as aluminum nitride also covalent in nature. So these two belongs to same type of solids. Coming to fifth question, the interparticular forces in solid hydrogen are. Solid hydrogen is H2 solidified. So as you know, when H2 is solidified, the actual valency of hydrogen is one only. One hydrogen can bond with another hydrogen only. So H2 molecules, when they are solidified, like inert gases, okay, like inert gases, between the molecules, which type of forces exist? Okay, between the molecules, which type of forces exist? So between the molecules, what type of force exists means one-to-one type of force exists. That is, either you take inert gases or you take like a solidified iodine or solidified anything it is. Basically, these type of gases, when they are solidified, the intermolecular forces will be weak one-to-one forces in case of inert gases also. So the option is option A. So we'll continue with next question. Let's see next question. Question number 6. Which of the following is not the property of crystalline solids? You know that solids basically classified into crystalline solids and amorphous solids. You know the characters of amorphous solids and you know the characters of crystalline solids. What is the basic difference between them? It differs by the arrangement of atoms. If the atoms are arranged regularly in long range ordered arrangement, then it is crystalline solid. If the atoms are arranged in short range irregular arrangement, it is amorphous solids. Right? Let us see what the question is asking. Which of the following is not the property of crystalline solids? Which one is not? Be careful in that. They are asking which one is not the property of crystalline solids. Crystalline solids have definite geometry, right? Yes, that is correct. Crystalline solids have sharp melting point. It is also correct. And now the option C is isotropy, option D is anisotropy. Now, which one is correct option, C or D? What is the difference between isotropy and anisotropy? Isotropy means if any physical quantity, refractive index or any electrical resistance like that, if it is measured from any direction in a crystal axis, you should have same value in all the possible directions. You should get same value by measuring at any angle. You should get same value. Anisotropy means you will not get same value when the same property is measured in different directions in any crystal. So, which one suits for crystalline solid? Actually, crystalline solids are anisotropic in nature, except cubic crystals we studied. Okay, optical activity, optical refractive index for cubic, except that all the crystalline solids are anisotropic in nature. All the amorphous solids are isotropic in nature. That means this property belongs to, isotropy belongs to amorphous solid. It is not crystalline. So answer is C. Let's go to 7. Which of the following is not crystalline? Okay, in all the given compounds, which is not crystalline, they are asking. Zinc sulfide is ionic compound, it is crystalline. Silver metal is also crystalline. Glass, you will study that plastic, glass, rubber does not belong to crystalline solids. They are all amorphous solids. And in glasses, quartz belongs to crystalline solid. Okay, it is also type of silica, but it belongs to crystalline type of solid. Glass does not belong to crystalline. It is amorphous solid. So, which one is not crystalline means amorphous. Amorphous means glass. Clear? Next. 8th question. Which of the following does not belong to same type of crystal? There are 4 crystals given to us. They are asking which one is odd among the given options? Means quartz is crystalline solid. Okay. Similarly, diamond is crystalline. Okay. Silicon carbide and iodine. They are asking which type of solid it will not miss. They should belong to same type. So which one belong? Which one does not belong to same type? They are asking. So quartz means it is a type of glass, covalent solid. Quartz is nothing but silica, covalent solid. Silicon carbide is also covalent solid. Diamond is also covalent solid, whereas iodine is molecular solid. So this is covalent, this is covalent, this is also covalent. Which one does not belong to same type? These three are covalent, but this one is molecular. Okay. So iodine does not belong to same type. Means among the four options, three are same type. Okay. These three are covalent, except iodine, which is molecular solid. Let's move on to next question. Ninth one. Number of basic type of unit cells among the crystals is. Now we have studied in solid state that there are 7 types of basic unit cells, and along with their variations there are 14 types of variations. 7 types of basic crystals, 14 types of all the different variations, we call it as Bravis values. But our question is asking how many types of unit cells are existing. We don't want variations here. If they ask variations, answer should be 14. But they are asking only type of unit cells without variation. How many types? 7 types. Okay, that is cubic, tetragonal, triclinic, rhombohedral, monoclinic, hexagonal, orthorhombic. These are all 7 types of the crystal unit cells. So the answer is C. Coming to 10th one. If A, B and C and alpha, beta, gamma are adjacent angles of the unit cell, then orthorhombic unit cell is described as orthorhombic unit cell dimensions we want. So you know that in orthorhombic unit cell all the edges are unequal, means A is not equal to B is not equal to C. All the edge lengths are different only. But all the angles are equal to 90, means alpha is equal to beta is equal to gamma is equal to 90 degrees. So which option matches with that is B, option B. Okay, A is not equal to B is not equal to C. Alpha equal to beta equal to gamma is equal to 90 degrees. That describes orthorhombic crystal. Okay, so with this we will continue next. Next question is 11th one. Which of the following is not a crystal system? You know that triclinic, rhombohedral, tetragonal, all these are types of crystals. What about the option D? Isomorphous. Isomorphous and polymorphous are not the types of crystals. They are just the classifications like allotropy in case of elements. Now, what is allotropy? If same element exists in different types of solids, then it is allotropy we call it. Like that only, if different compounds exist in same type of crystal lattice, then that type of phenomenon or that type of crystals we call it as isomorphous crystals. So this is not the basic classification of crystals. This is not a type of crystal system. It is a classification. So option D is not a crystal system. 12th one. The most unsymmetrical crystal system is. The most unsymmetrical crystal system means you need to look at the dimensions. That means A should not be equal to B should not be equal to C. Similarly, all the angles must be different. Okay, all the angles must be different cubic crystal. In cubic crystal, A will be equal to B, B equal to C, alpha equal to beta, beta equal to gamma, gamma equal to 90 degrees. What does that mean? All sides are equal, all the bond angles are equal. When all sides and all bond angles are equal, then that crystal becomes a highly symmetrical crystal, right? All sides are equal, means you can make a number of symmetries in that. You can see different types of symmetrical axes. But we want the most unsymmetrical crystal system. Among the given options, which is most unsymmetrical crystal is in that all sides must not be equal to each other and all the bond angles must not be equal to each other. That is triclinic system. It is most unsymmetrical system. Okay. Coming to the next question, 13th one. The unit cell with crystallographic dimensions A equal to B, B not equal to C, alpha, beta, gamma is equal to 90 degrees is. Now you need to memorize this all alpha, beta and this ABC values, so that you need to remember the type of crystal systems. So all the 7 crystal systems, all the ABC and alpha, beta, gamma values, we need to memorize this. So out of this all, which one is the belong to this type of system means A equal to B not equal to C, these are all equal to 90 degrees is tetragonal system. It is tetragonal system. Coming to 14th one, a crystal system has the following, they have given some values to us and they want us to know which type of crystal system it is. Now the meaning of giving the values here is A 0.4 to B 0.49, C 0.56. Meaning is A is not equal to, the meaning of this values is A is not equal to B is not equal to C. That's what they want to say us. Just for confusion, to create the confusion, they are giving different values. So the ultimate thing you need to understand is A is not equal to B, not equal to C. And alpha, gamma equal to 90 degrees, but beta is not equal to 90 degrees in this crystal system. So which type of crystal system belongs to this particular type? So that is, in case of monoclinic crystals, okay, in case of monoclinic crystals, this thing happens. Okay, alpha, beta and is 90, but alpha, gamma is 90, but beta is not equal to 90. Okay. Now coming to the 15th question. Okay. 15th question is, so the smallest repeating, sir, 1 minute. The smallest repeating pattern which repeated again and again results in the crystal of substance is porous. Okay. The smallest repeating unit in any crystal system, what we call it? We call it as a unit cell. We call it as unit cell. Smallest repeating unit in crystal system is unit cell. When it is repeated again and again three-dimensionally, then the original crystal lattice is produced. So that is about the 15th question, option C. We will continue in the next class.